Hello friends, welcome to my channel. Let's have a look at problem 505 together, the maze 2. In this video, we're going to share a solution based on breadth-first search plus relaxation. So this problem is actually a continuation of problem 490. In that problem, we're asked to judge if there is a valid path from the start position to the destination position following the rule of rolling of the ball. And in this problem, we are asked to return the corresponding distance if there were such a path. So let's look at one example to get a better feeling about this problem. So for this problem, the output is 12, and so this is the one possible way: left, down, right, down, and right. Then if we add the passes or steps together, that is 12. So we shall not repeat the constraints on this problem because that's the same as those for Leetcode 490. So here the method we're going to share is essentially the Dijkstra's algorithm, but we didn't use a min heap in here. So it's good to have a look or check out the video explanation for Leetcode problem 490. So here our plan is as follows. In the current video, we're going to write a breadth-first search solution plus a relaxation. So essentially we are reusing the code from Leetcode 490. The container is the queue. So in a follow-up video, we're going to write a standard Dijkstra's algorithm solution using min heap. So with that said, let's look at the code, and hopefully it speaks itself. So first, we're going to track the number of rows and number of columns in the maze. So next, we're going to initialize a container. So here the container is a queue, as we are going to do a breadth-first search. So next, we're going to have a way to mark which spaces are already visited. So let's use a table. So in the previous video for Leetcode 490, we're using the trick of marking the position as a different number, right? So here let's just do the table in order to easily do the relaxation. So here I'm going to use -1, so times n for a dummy variable runs from range m. So the reason we are using -1 as initialization is because this return -1 assumption in the problem statement. So once that's done, we're going to first mark the start position as 0, so which represents also the distance. So visited start 0 and start 1. So that's 0. So in other words, for index ij, so visited ij will represent the shortest distance based on the rule in this problem from the start to that position. So with that said, let's do the iteration. While queue, so we're going to pop from the left. In other words, we're using the list as a queue. So xy equals q pop 0. Then we're going to check the 4 directions, right? So for dr, dc in the 4 directions, that is -1, 0, 1, 0, and 0, 1, 0, -1. Then first let's fix the position we start. So rc and the current count or increment. So that is x, y, and 0. And then we choose one direction and then move along that direction until we hit a boundary or wall. So while r is in range and c in range, say 0 less or equal than r less than m, and 0 less or equal than c less than m, and means rc is 0, then we continue move towards that direction. It's corresponding to update this rc and count by r plus dr, c plus dc, and count incremented by 1. So that's the while loop. Then after we exit this while loop, we either hit a boundary or a wall. Then we need to move one step back. So this corresponds to update rc and count by r minus dr, c minus dc, and count minus 1. So now, as in the previous solution for Leetcode 490, so we're going to check some conditions. So here is that if visited rc equals -1, in other words, the position rc is not visited yet, or if it's visited but rc is greater than visited xy plus the count. So the latter is the current shortest position from the xy up to this rc, right? So this one, if this condition holds, then we are going to reset this visited rc by visited rc equals the smaller one. So this if condition is nothing but the relaxation step. If you compare with the Dijkstra's algorithm. So once this is done, then we're also going to append this current position to the queue or in queue that. So append this. Let's see. We're going to use a list. So that's rc. So that's about it. So after this while loop, actually we are ready to return the result. We just need to check the corresponding number or value at visited at this D position. So D is the destination. We change this to be a capital letter just for the convenience of writing. So we're going to return visited and D0 and D1. So if this value is -1, it means that no such path. Otherwise, it gives us the shortest distance. So with that said, let's do a special case check. It passes one special case. So now let's look at the generic case. Oh yeah, it passes the generic case. I guess for this video, what can be important is that in order to get the shortest path, a vanilla method is breadth first search. So here we used relaxation, but without using min heap. Essentially, we are doing the same of Dijkstra's algorithm. So in the follow-up video, we are going to write a standard Dijkstra's algorithm solution for this problem with the help of min heap container. So with that said, I guess that's it for this video. Thank you very much.